discuss the chemistry, let's first look at the situation. Every morning, Sarah helps her mother prepare breakfast. Her grandmother has a simple habit. She always adds a teaspoon of salt into the water before boiling eggs. She believes that this makes the eggs cook faster and also prevents them from cracking. Many people follow this practice in their daily lives. But have you ever wondered whether this is just a traditional belief or whether there is actually science behind it? From a physical chemistry perspective, adding salt changes some properties of water and also affects how the egg proteins behave during cooking. These scientific principles help us understand why this kitchen practice may have certain effects. So let's explore the physical chemistry concepts behind adding salt to boiling water. There are three main physical chemistry concepts involved in this case study. First is colligative properties. Colligative properties depend on the number of dissolved particles in a solution, not the type of particles. When sodium chloride or table salt is dissolved in water, it increases the boiling point of the water. This is known as boiling point elevation, which can be represented by the equation delta TB equal to IKBM, where I is the Van Hoff factor, Kb is the boiling point elevation constant, and M is the molality of the solution. However, for the small amount of salt normally used in cooking, the increase in boiling point is very small, usually less than 1 degree Celsius. Therefore, the eggs do not actually cook much faster. The second concept is ionic strength. When salt dissolves in water, it separates into sodium ions Na+ and chloride ion Cl-. These ions increase the ionic strength of the solution. If an egg develops a small crack during boiling, the ions can help the egg with protein coagulate more quickly around the crack. As a result, the egg white seals the crack faster, reducing leakage. Finally, protein denaturation. Egg whites contain albumin proteins. When heated, these proteins unfold from their original structure and form new bonds with one another. This process is called protein denaturation. In salty water, the presence of sodium and chloride ions can slightly influence how these proteins interact, helping the proteins coagulate more effectively, especially if the egg shell cracks. So, in conclusion, the main benefit of adding salt is not to make the eggs cook faster. Instead, it slightly raises the boiling point and may help reduce egg white leakage by promoting faster protein coagulation if the shells crack.
So, does Cramer's trick actually work? Let's find out with some real numbers. I will walk you through the calculation for our case salt in boiling water. Step 1 is finding the mass of sodium chloride. Cramer's teaspoon of salt, that is sodium chloride, weighs 5.69 grams. Not much, right? Let's see what it actually does. Step 2 is converting that mass into moles. The molar mass of sodium chloride is 58.44 grams per mole. So, 5.69 grams divided by 58.44 give us 0.0974 moles of salt dissolved into the pot. Step 3 is calculating the molality. Since Sarah's mom is using 1 liter of water and water conveniently has a density of about 1, that is 1 kilogram of water. So molality equals moles divided by kilograms, 0.0974 moles per kilogram. Simple enough. Step 4 is calculating the boiling point elevation. The formula is delta TB equals I times KB times M. Here, I is the Van Hoff factor, basically how many pieces the salt breaks into when it dissolves. Sodium chloride spills into sodium and chloride ions, so I equals 2. Salt does not just dissolve, it multiples its effect. Kb is the boiling point constant for water, which is 0.512 degrees Celsius kilogram per mole. That is just a fixed value of water. Multiply it all together. 2 times 0.512 times 0.0974 equals 0.10 degrees Celsius. Step 5 is finding the new boiling point. We take the normal boiling point of water, 100 degrees Celsius, and add our 0.1 degrees Celsius increase. So, the new boiling point is not 100 degrees Celsius anymore, it is 101 degrees Celsius, a whole 1/10 of a degree hotter. So, technically, the water is slightly hotter, which means the egg does cook a tiny bit faster, but the difference is so small, it is barely noticeable in real life. We are talking a fraction of a second difference, not something you would actually feel while waiting for your egg. But what about prevents cracking? Here's the twist. Salt does not actually stop the shell from cracking since that is caused by air pressure building up inside the egg as it heats. But what salt does do is help seal the crack faster if one happens. Because salty water is denser, any egg white that leaks out coagulate quickly, sealing the gap before more escapes. So grandma is not completely wrong. She is just describing damage control, not crack prevention.
Based on our findings, the 0.1 degrees Celsius increase in the boiling point is scientifically real, but it is too small to significantly reduce the cooking time of eggs. So, the common belief that salt makes eggs cook much faster is not supported by science. However, adding salt still provides several practical benefits. It helps seal cracked eggs by promoting protein coagulation through ionic strength, enhances flavor, and remains a long-standing cultural practice that has been passed down through generations. As Muslim and Khalifah, understanding the science behind everyday practices allow us to make informed decisions while appreciating the wisdom found in our daily lives. Thank you.